Welcome. In this video series, we're going to look at linear equations, their properties, their graphs, and then also get into functions. So we'll get there eventually, but we're going to start off with linear equations. And so when we think of linear equations, or at least as mathematicians think of them, we think about one of three different forms. And you can see the three different forms here. We have slope-intercept, which is the number one form that students like to default to, and I'm going to tell you that is a trap. It is a lot more work to get in that form compared to point slope form, because really all you need is a point and a slope. We'll talk about that concept of slope in a bit. And then the other form comes later in your mathematical career called standard form. And so generally you won't see that at this level, but it does come in quite useful later on in your mathematical life. And so when we see these forms, right, that's the algebraic form, right? And we can move between different representations quite easily. So we can take these forms, these algebraic representations, put them in what we call graphs or tables, or even do written descriptions. And so when we look at the graph, for instance, right, because we're focusing on graphs primarily in this video segment, we recognize that when we think of a linear equation, it's called linear because the graph is a line, and that line, when we graph it, contains all solutions to the equation. Okay, so for example, if we want to verify that 0, -3, and 2, -6 are solutions, right, all we need to do is when we write these as ordered pairs, these are x and y values, so we just have to substitute them in. So we can do that. And so we just substitute them in, and we verify that you get the same value on both sides. Okay, that's fine. And then it says use these points to generate the graph of the equation. So really, to generate the graph, it'd be 1, 2, 3. I'm going to just plot the points, right? This is x and this is y. And then we go 2, and then we go down. Let's see, that's 3, 4, 5, 6. So then I get something like that. And then the line that I would make that connects these 2 points is something like that, and that line would be all solutions that satisfy the equation 3x plus 2y is equal to -6. Okay, easy peasy. Okay, another fun thing that we can notice is that the point that we have 0, -3, that intersected an axis, right? And that when that happens, we call that point an intercept, and we actually can label it even further, and we call that the y-intercept because that's where it meets the y-axis. Similarly, there is a point, and you can kind of see it here, where the graph of the equation would meet the x-axis, and we'd call that the x-intercept. And so graphically, we just have to identify, where they meet the respective axis. Algebraically, it's maybe a little bit more work, because if we wanted to find the y-intercept, even though we found it algebraically, we'd have to replace x is equal to 0 in the equation to solve for y. And that actually makes sense, right? Because when we look at this was our y-intercept, right? The x value is 0, because we haven't moved horizontally, and we just moved down 3 units. Now, to find the x-intercept, we'd have to, set y equal to 0 because we haven't moved vertically and solve for x. And then that is exactly what we're being asked to do. Okay, so I would need to follow the instructions. So set y equal to 0. So I would leave x as unknown and then replace y with a 0 equals -6. 3x equals -6. Divide by 3. And I get that x is -2. So when we write intercepts, it's always a coordinate. So we need to write it in as an ordered pair x comma y. The last big property that we're going to look at is derived from kind of the table and the pattern that we see from a linear equation in a table. So if we look at the table form, right, I have a table of values x, and then so I chose x values that were nice, -2, -1, 0, 1, 2, ran those through the equation, so put in x, solved for y, and I got those values there. But what I can notice is that in the table, as I increase by 1 unit in x, right, I'm always increasing by 1. What happens in y? Well, y is decreasing by 1.5 here, and then decreases by 1.5 here and here, and here. And so this change amount for a linear equation is always going to be constant in y. And that leads us to this idea of slope, which is the ratio of how the y value changes to how the x value changes. And so you can see the formula, and you probably remember this is rise over run. And so that's why mathematically it might be more practical for us to remember that slope, which is represented by m, is calculated as y2 minus y1 over x2 minus x1. Okay, and this interpretation will be critical in pre-calculus 1 when you take that. But it's the idea that as you change 1 unit in y, which 1 unit in x, I'm sorry, as you see in the table, y increases by a constant amount. Well, in this case, it would be increases by a negative 1.5 or decreases by 1.5, either way. And so if we want to determine the slope of the graph, right, it's kind of evident in the table, but if I wanted to use those 2 points from earlier, right, I had 0 minus 3, and I had 2 minus 6. So if I were to use those to generate the slope, I'd have m is equal to, let's see, negative 6, minus a negative 3 all over 2 minus 0. So in the numerator, what do I get? I get negative 6 plus 3, that'd be minus 3, denominator 2, also known as 1.5 as a decimal. Okay. Now, in some cases, these lines that we draw, the graphs of the linear equations, might not be diagonal, right? We saw that this one was diagonal. Other cases, they might not have happen to be diagonal perfectly. They could be vertical or horizontal. And so what is slope in those cases? Well, so each of those, you know, we have 2 different scenarios here. What you can imagine is for, I'll do this one in blue, if we look at x and y, right, no matter what x is, right, or x, this is saying x is always 3, no matter what y is. So I could do something like this, and I just get a bunch of points. And so if I were to graph that, it'd be, you know, here is 1, 2, 3, and then 1, 2, 1, 2. And so I have these points that are looking something like this. And so I get a vertical line. So whenever it's of the form x equals, that's a vertical line. By comparison, when I look at y equals negative 2, right, if I were to make the table of values for that, right, I can pick whatever x's I want, and y is always going to be negative 2. Okay, and so if I look at the associated graph, right, let's see, so I go 1, 2 in every direction just to save myself time, and x, when x is minus 2, I get negative 2, and then, you know, negative 2, negative 2, negative 2, negative 2. Okay, so I get this nice horizontal line, okay? So equations of the form y equals give a horizontal line, and so here I end up with a in a case of a horizontal line, I get 1 vertical intercept. Okay, and in the case of a vertical line, I get 1 horizontal intercept. Okay, and so I think that is just another thing to be aware of in addition to all of this. You might also want to think, you know, in these cases, what are the slopes? And so spoiler alert, in a horizontal line, slope is 0, and in the case of a vertical line, we would have an undefined slope. I'll leave it to you to do the calculations. All right, so that is a bit of a longer video, but kind of a quick overview of all things related to linear equations and their properties.